Oh, dear friends, in this we'll discuss to find out series solution of a differential equation. Our topic name is series solution of differential equation. First of all, we will recall some idea about differential equation and then I will move towards this article. Now we are knowing how to find solution of differential equation. This is first order and first. We are knowing there are several methods to find out solution for linear differential equation of first order and yeah, any differential equation of first degree. Various variable acceptable exactness. This is not exact, then we have to find finding for integrating factor. In this, one more is to find out linear differential equation of first order and first degree in this form. Dy by dx plus py is equal to p and q. These are the constant coefficients. And then we can find out, we can find not constants, something that maybe p and q may be constant as well. In this case, we are finding integrating factor p into dx, and solution is y into this factor integration, this integrating factor into this q into dx plus famous equation, find out the solution of linear differential. After this, we are knowing higher order. Higher order linear differential. Linear differential. Higher order linear differential equation, you can write here this equation they call here for third order dy by dx plus some constant q1 into d2 by dx2 plus p2 into dy by p3 is equal to. Now here p1, p2, p3 are constant and q is constant or function of x. Constant or function. Now here in this equation also we are getting solution as y is equal to cf plus pi. We are knowing this. We have to complement and pi particularly for constant. If we are extending this idea, then we'll get this type of equation: x cube into d cube pi by dx cube plus x square into d2y by dx2 plus again I will take some a1 into x into dy by x. Here also I will doesn't matter. Plus y is equal to something. Okay. Now this is our equation, but this is with constant coefficient. These coefficients are not constant. X square here is x means here this p1, p2, p3 are constant. You can take p0 also. These are the constant. But here these are not the constant. Therefore, this type of equation we know again how to solve that equation. Particularly, we are knowing that this is Taylor's equation, and we can reduce this equation into linear form by putting some z is equal to log of x by using this solution. Now We will come towards our idea to find out solution for differential equation. Suppose I will take one example. This is the d2y by dx2 plus y is equal to 0. Now this is a linear differential equation. This is linear differential equation. To find out this linear differential equation, CF complementary equation, and directly we'll get solution as a into sine x plus b into, how we are getting, we are getting CF part here from this equation. We are getting auxiliary equation, this is b square plus 1 equal to auxiliary equation, and roots of this auxiliary equation is plus or minus. And if roots are complex, then we are getting solution of sine x function. These roots are, suppose I will write d is equal to plus or minus, then our solution e raised power alpha x into c1 into cos beta x plus c2 into sine beta x. By using this way, we are getting here solution in so sine and cosine. But we are knowing that for this sine function, we can write series form of sine x. And moreover, we are knowing here Maclaurin expansion, Taylor's expansion. Sine x. What is series expansion of sine x? X minus x cube divided by 3 factorial plus x square divided x raised to 5 divided by 5 factorial minus x raised to 7 divided by 7 factorial plus so. Means we have to take odd terms alpha. And cos function is 1 minus x square divided by 2 factorial plus 2 divided by 4 factorial x divided by 6 factorial and right here. Just I am recalling, and we know this famous formula for e raised to x. Function for e raised to x is 1 plus x square divided by 2 factorial plus cube divided by 3 factorial. This is sin x and cos x. I can replace sin x and cos x by this series form and we'll get solution of this equation. This is y equal to this solution a into sin x plus b into cos x in set. Now, but what is method to find out series? Now we'll discuss. Now I will try to find out. We'll take one example and I will try to find out series solution. So to find out series solution, one thing is very important. First of all, I will try to find out series solution of differential equation. Now, why we need to find out series? Discuss that thing also, and we will try to find out series solution with some. Now here, we'll take one example after discussing some basic part of given equation, and then we'll go ahead for our. So now, up till now, we are knowing how to find out linear solution for linear differential equation. Moreover, Taylor's equation. Now I will consider second order differential. 2y by dx plus p of x into dy by x plus q of x into y is equal. Now this is differential equation where p of x and q of x, these are the polynomials in x. These are the polynomials. Now, for some value of x equal to, if I will take any value, and if for these values of x, if my function vanishes, or that becomes a 0, then instead of 0, I will take, suppose this is not equal to 0, then we are saying that this point is a ordinary point. Okay. I will come towards examples. Only I will dictate here idea. If I will write here for x is equal to a, for this function p of x is not equal to 0 and u of x is not equal to 0, then x equal to a is or ordinary. X equal to ordinary. Okay. When we are saying that this is ordinary point, any point you can take, p of x and q of x should not be, sorry, infinity, should not be infinity. Should not be infinity. Infinity means disconnected point. On that point, if our function is disconnected, then we are not taking. Then we are saying that these are not ordinary points. These are the singular points. And otherwise, we'll say that these are equal to a is when we are saying that singular point, if our is at this point, our function becomes infinite. In this case, that is p of x equal to infinity and p of x equal to infinity. Then we are saying that this singular point. Again, I will go towards particularly. Take here example. Suppose I will take this example d2y by dx2 plus right x square into d2y by dx2. This is a 2x square minus x into dy by dx plus y is 0. This is my difference. Now see here carefully for this differential equation is not in Euler's form. Therefore, we will not solve this equation easily. Therefore, we need new technique. Now I will write this equation d2y by dx2 plus 2x square minus x divided by x square into dy by x plus 1 divided by x square into y is 0. That means I am dividing x. See, this is my e of x part. Means I will write this equation d2y by dx2 plus e of x into dy by dx plus q of x into y. Now here, tell me for which value this p of x becomes. This is our p of x. P of x. So p of x is equal to infinity for x equal to 0. The same for q of x also. And also q equal to infinity for x equal to 0. Therefore, x equal to 0 is not. Okay? This is not an ordinary. Now I will take here easily write. I will write here 1 plus x square into d2y by dx2 minus x into dy plus y is equal to 0. How? Now we can write here p of x. Here I will write now y double dash. d2y by dx2 I will write double prime dy by dx time. Henceforth, now remember that I'm power. Plus here minus x divided by 1 plus x into y prime plus 1 divided by 1 plus x square into y is equal to 0. Now this is my p of x. P of x, q of x, for x equal to, for which value this becomes 0, 1 plus x square. 1 plus x square equal to 0. Now x equal to plus or minus I, imaginary value. That means here, for real value, this is not. Means you can take any real value, this becomes ordinary point. X equal to 0. Ordinary. Is it clear? You can take x equal to 0, anything. Never becomes infinite. So I will say that x equal to 0. Single order. Okay. Now, if for our any equation, if x equal to 0 is ordinary point, then how to find? Find any solution of differential equation with ordinary point at x equal to 0. Means if x equal to 0 is the ordinary point, then we will try to find out. We'll try to find out series solution. Now, how will we find series solution? Here, you can take any equation, but x equal to 0 should be ordinary. Now, it's clear that ordinary point means p is not equal to infinity. P of x is not equal to infinity. Then we are saying that this term. In this case, take solution as any differential equation second order is given. We are taking solution as y is equal to a0 plus a1x plus a2x square plus so on. I will write n into x or in symbolic form. I will write n into x power n is equal to infinity. This is my solution. And we have any. Suppose we have this equation dy by dx plus p into dy by dx plus q equal. This is my differential equation. And for this differential equation, x equal to 0 is ordinary. X equal to 0 is ordinary. Then we can write our solution. And basically, we are considering here only first order, second order differential equation. That's why I will here y or y prime or y prime. What will be dy by dx? We have this y. Then we can write a1 x a1 plus 2 into 8x. We have to differentiate. Plus last general term n into x raised to power n minus. This is a differential. In symbolic form, you can write this as n into x raised to power n minus. That means everything differentiate this term. But n varying from 1 to second derivative d2y by dx to y double prime. I will write here directly n is equal to 2 to infinity n into n minus 1 an into x raised to power n. And we have to put equation 1, 2, and 3 as per given our equation. If we are putting these values in this equation, Then we are getting finally comparing all to it. We are getting the solution for series solution for our differential. We'll enjoy by taking one example. Solve one example and I will find series solution of e2 plus y equal. Actually, this is easy one, but for practice, I'm taking this example and I will try to find out series solution for this. It is very clear that the solution for this is y is equal to a into sin x plus b. This is solution. We are getting this. But we'll use here series solution method in the meantime. For this method, it is clear that clearly x equal to 0 is ordinary. X equal to 0 is ordinary. If x equal to 0 is ordinary point, then solution of given differential equation is directly read on this. A0 plus A1 into x plus A2 into square plus so on. I'm giving this. This is solution or actually answering over here. Only our duty is to find out write this solution is n in x raised to power n equal to 1 to infinity. Okay, in short, only equation 1 is our final answer. Our A1, A2 is constant. Now we'll try here. As per given equation, this is the given equation. In this given equation, double derivative of y is there and y is there. Therefore, we need to find out directly find. Therefore, y is equal to n into an into x raised to power n minus 1. I hope you are getting. And n varying from 1 to infinity. We are getting this. Again, I will find y double prime is equal to summation n is equal to n into n minus 1 an into n minus 2. Is it right? By taking help of these three equations, I will write our given equation. Therefore, given differential equation becomes what is differential equation? Right. Prime plus y is equal to 0. Therefore, I will write double prime n equal to n in n minus 1 n into x power n minus 2 plus y only. What is y? This is summation n equal to n into x power n. Using this equation, we'll try to find out unknowns. A0, A1, A2, A3, these are the unknowns. We'll try to find out. Now see here, this series start from n equal to 2. This series start from n equal to 2. And here x raised to power n is there. Here x raised to power n minus 2. Therefore, when we are taking addition of polynomials, power should this power x raised to power n, x raised to power n. We can add coefficient or same power. Therefore, I would like to convert this series into same power. Okay, I will do one idea about to convert series here. Suppose I will take this is n into x raised to power n and n is equal to 1 to infinity. Series. I will type k. These are the domains. And k is equal to. So what we have to do? If x raised to power k power is there, and I would like to change this power, let him minus. If we would like to change this power k minus 2, then this power we would like k minus 2, then what we will replace what we have to put, then this power becomes k. What we have to put, then this power becomes k. Means if I will replace this k by k plus 2 and then this minus 2. I'm doing, I'm replacing k by k plus 2 and this minus 2. Then yes, this total power becomes k only. Because we need this n power. Here is n. Therefore, I would like to replace here. Therefore, I will replace here. Okay? K I am replacing by k plus 2. K plus 2. X raised to power k plus 2 minus 2. This and here, this is k plus 2. K plus 2 is equal to 1. From this, I will take to this side. This minus 1. Or if I will take this from 2, then this directly becomes k equal. Series becomes a k equal to 0 to infinity, k plus 2 into x. I hope you are getting it. I'm using the same idea. Now what I'm doing, I'm changing this power. I would like to convert this power into n. Therefore, what we have to do? Write this power into n. We have to replace n by replacing n by n plus means anywhere we are getting this n. Replace this n by n plus. Here I will write summation n plus 2 m replace. Here is n minus 1. I am replacing n by n plus 2. Now this minus 1. A n plus 2 into x raised to power n plus 2 minus 2 directly n plus this term as it. A n into x raised to power n 0. N equal to 0. We are not making any change in second. But here n is equal to 2. I am taking here n minus 2 equal to 2 because I am replacing n by n minus 2. Therefore, this equation n equal to 0, n plus 2 into n plus 1 into n plus 2 to power n plus n into x raised to power n is equal to infinity. Now see here, this cell started from 0. This is also starting from 0. X raised to power n, x raised to power. Therefore, we can add it. Therefore, I will write n is equal to 0 to infinity. N plus 1 in n plus 2 n plus 2 plus an into x raised to power 0. I will add it. Now, for this series, x raised to power n, these are the all coefficients of x raised to power n, which is equal to 0. That means this coefficient must be equal. Therefore, I will write here n plus 1 into n plus 2 n plus 2 plus an is equal. And from this, we'll get n plus 2 is equal. And here, n varying from n is equal to 0, 1, 2, and so on. 2 is equal to minus n divided by n plus 1 and n plus 2. And n varying from n. Now I would like, we are getting this as a representation. And we will try to find out values of a0, a1, I will put n equal to 0, then what will happen? N equal to 0. A2 is equal to minus a0 divided by n equal to 0. I am putting it. This is my final representation. By using this, I would help of trying to find. Yeah. I'm putting n equal to, we are getting 1 a3, because I'm putting n equal to 1 here. I'm putting n equal to 1 here, so we are getting a3 equal to minus a divided by, I'm putting n equal to 1 here. This is 2 into, now I will put n equal to 2. We are getting a4. a4 equal to minus a2 divided by equal to 2s. 3 into 4. But a2, what is a2? This value of, therefore this becomes minus plus, and we are a0 divided by 1 into 2 into 3. Similar way, I will find out a5. N equal to a5, we are getting here minus. Here, this is important equation. N is equal to 3 here. We are getting 4 into 5, which is equal to a3. A3 is calculated. It is, our a3 is minus a1 divided. I will put here minus become plus. A1 divided 2 into 3 into 4. Similarly, we will get a6. What will be a6? Will be, if odd terms are there, if odd terms are there, we are getting a0, and here a6 is there, we are getting a. But find out, right here directly. A0 divided by, now this sign becomes a minus, and here we are getting 1 into 2 into 3 into 4 into 5. That means this is minus a0. We'll write this as a0 divided by 4. This as a1 divided by 5 factor, and a7. How will get a7? a7 is equal to, now minus a1 divided by 7 factorial. Yes. In general, we are getting this value. Depends on even or odd. Therefore, equation 1 can write and calculate all these values, and this is our equation. This is our final solution. I'm putting these values in equation 1, a0, a1. Y is equal to a0 plus a1 into x plus a2. What is a2? Calculated. a2 is equal to minus a0 divided by 2 factor. Minus a0 divided by 2 factor plus a3. a3 is minus a1 divided by 3 plus a0 divided by 4 factor plus a1 divided by 5 factorial, and so on. We'll write these terms. We'll collect a0 terms. That a0 into 1 minus 1 divided by 2 factorial plus 1 divided by 4 factorial. So x terms are x square plus a1 into a1 x minus cube divided by 3 factorial plus x is to 5 divided by 5 factorial, and goes on plus. This is a0, and this total is nothing but series of cos function plus a1 into 5. So we are knowing that this is our final solution. But only we are using the solution. We are finding the solution. Same we are getting. and we are getting okay. Okay. Now I will give one assignment homework to you. Try to find out series solution for find series d2y by dx2 plus x into y equal. Okay. Solve this as homework. Okay.